Okay, yeah, this is the this is the first problem I'm solving, the two sum in the lead code. So basically, what we'll have to do here is we'll be given an array list of numbers, and we'll be given the 9. Okay, so we are like, I mean, we got the number 9. So what we'll have to find is we'll have to find which two elements I need to add to get this number. This is what we'll have to find. But one thing is, you just don't need to send the, let's say that here, right? To get the 9, what I need to do is, just by looking at it, I can say that if I add this 2 plus 7, I will get a 9. So ideally, like, I mean, we are not returning 2 and 7, we are not returning 2 and 7. Instead, we'll have to return the indices of it. Okay, this is the problem about. So similarly, we can say here we have a list of numbers, and we have a given number target as 6. Okay, so now what I will have to do is, in generally what we'll do, like, we'll have to start from the beginning. We'll say that 3, right? O of n square solution would be like 3, and I will check it with this 2. 3 plus 2 is 5. Is it equal to 6? No. Then what I will do, and next I will 3 plus 4. Is it equal to 6? No. 3 plus 4 is 7, so it is not. So now next I will go to 2, and then I will check, compare with 2 plus 3 is 5. No. And then again, what I will do, 2 plus 4 is equal to 6. Then I will pick these two numbers, and I will return the indices of it. This will be like a O of n square solution. That was my initial solution. So okay, yeah, that was like, I mean, that was a time complexity wise, it's a. So next thing is, when I just searched through the internet, I found this easy solution, which is, we'll have to take the complement of it. So what is this complement about? Okay, so now what we are doing here, we have a final number, right? We have a final number, we have an initial number too. So what we are looking now is, we have a, and what is it exactly is, a plus b is equal to c, correct? So c is 9. So I have a and I have a c. I need to find what is b here. Okay, right? 2, what I'm doing here, 2 plus 7 is equal to 9. Okay, this is the one. Okay, and similarly here, right? 3 plus 2 is equal to 6. No, that is not correct. So this is what we are doing here. So instead, what we can do is, let's say that a plus b is equal to c, right? This is what the expression is. So now what we know, a we know, c also we know, we don't know b. So what we are going to do is, we'll take a complement of it. So we'll get this number, right? So let's say that 2 plus 7 is equal to 9, correct? And 9 minus 2 is nothing but equal to 7, right? So we'll get this number. So now what we'll have to do is, now what is the logic here is, so uh okay, yeah, let's me start with the flow. This is my old code. I will explain about the time complexity later. Okay, so first what we'll do is, we'll iterate through the list. Okay, we'll iterate through the list, and then what we'll do is, we'll take the complement of it. So basically, what is the complement here? So I go here 9, and so 2. So what will be the complement? 9 plus 2 is equal to 7, correct? So 7 is there. 7, we got the complement as 7 here, and we'll have to check if the 7 is present in this list or not, correct? Like, I mean, if it is found, then it means that we got a sum here, correct? So now we got it. We took a complement. Okay, 7 is also there. So it means whatever the number we are currently at, take the indices of it, and if 7 exists, take the indices of that. That is the final solution we'll get here. That is the solution that is being written here. Okay, and now let's analyze the same code for the next example. So 3 2 4. Okay, now the target is 6. Let's take the complement of 3. So 3 plus x is equal to 6, right? X is equal to nothing but 6 minus 3. That is the complement, right? 6. So what we are looking at here is, 3 is here. 3 plus x is equal to 6. Now the complement is itself is 3. Okay, and now if we run the same code without this logic, we'll run into an issue, right? Like, I mean, now what we'll do is, we'll be returning 0 comma 0 as a solution, but that's not correct, right? We'll have to return two separate, like, I mean, here it is mentioned that, somewhere here it mentioned that we'll be exactly getting the one solution. Okay, so it can't be like 0 comma 0 or 0 comma 2. It can't be that. It should be two separate indices, so we'll have to ignore that. So I've added that part here. So what we'll do now is, it will check first. It will check the complement first. What is the complement here? Complement is 3. Okay, and the next thing is, what we'll do here is, if the complement exists in this list, okay, yes, it exists. And also make sure that we don't pick the same indices. That is the check about. Okay, that is the check about. And then like, I mean, if it is the same index, we'll go to the next one. So similarly, that's what this code is about. And again, this will be like O of n square time complexity. So because we'll be finding out the indexes again and again, we'll be finding the indices, and we'll be checking if the number is present in the list or not. So it will be like we'll be iterating through the list internally in the Python code, like it will be iterating through the list, and it will try to find if the element is there or not. The worst time complexity would be like we'll be iterating through the end of the list, right? Like if you have some 100 numbers, and if our number is at the end, right, 100th element will be iterating towards the list, so it will be constituting the O of n time complexity. Okay, so yeah, this is like a kind of n square time complexity. Okay, not fully, but yeah, it's like O of n square. So now, after searching through the internet, I found this simple solution here. So what is the solution is, so before this we'll have to understand that time complexity for finding an element in a list, right, it will be O of n. But if you want to find an element in the any dictionary, right, it will be O of 1. Okay, on average it takes a O of 1. Okay, so now what we'll do is we'll iterate through it, like we'll start a for loop through it, and when we start through it, we'll store the index also. Meaning, let's say that I started with a 2. Okay, I started with the 2, I will store the 2 in the dictionary, and also I will store the index of it. Then I will go to 7, I will also store the index of it. 11, and store the index 15. Okay, we don't have to iterate through the fully first. I will see. Okay, so now I will go to the 2, and then it's the same, remaining things would be the same. I will check the, I will get the complement. Okay, I will get the complement. What is the complement here? 9 minus 2 is 7. I will check in my list, have I visited that node or not. Okay, have I visited that element or not. According to me, like we just started, right? This element is, this dictionary is an empty list, empty dictionary, right? So we won't be finding the 7 here, correct? So we'll be skipping, like we'll be updating our dictionary saying that this is found, this is already found. We'll be storing the index of the 2. Okay, and next element is 7. We'll go here, and now we will check. mm, Now we will check if the, what is the complement for what is the complement for this number. So 9 minus 7 is 2. We will check in the dictionary if we have already visited that node already, right? So 9 minus 7 is 2. Yes, we found this, like meaning, we already visited this node. We already know visited this element, so it means that we'll have to return the whichever indices which was already stored, right? 2 was already stored, get the indexes of it, and get the index of this also. We have already stored, so will be already found, will be returning already found of remaining, and this, that is it. So basically, to give an overview or to summarize here, right, so we will, the first basic thing is we'll have to go up with the complement logic here. And the second thing is like how we go about it. Like if you want to go with the list, it will increase the time complexity. So to reduce the time complexity, we'll have, it is better to have one dictionary and store the indices. And then as you keep on iterating through it, just update the dictionary. Okay, just update the dictionary, and just update the dictionary, and when you do the analysis, just check if the element is already exist there, right? Like if you have already visited that element or not. If it is element is already visited, it means that it is a two sum, right? And then finally return that element. Yeah, that's it. Thank you.